Good morning, gentlemen. So this morning is the 25th of March. You had these questions here assigned for homework over the past few days, 2016 question 4 and 2014 question 9. Both of these are on paper 1, by the way. So calculus would have been on paper 1, or it would tend to be on paper 1. It could come up on paper 2, but it's highly unlikely to do so. Okay. So that's what we're going to look at now in this video, and then for Monday, okay, so for Monday I would like you guys to have done the entire of the 29 paper 1. Okay, so have a go at the entire of the 29 paper 1, so you can work away at it, keep doing little bits every night or whatever. Now I will be seeing you guys again on Friday, so if there's a problem, if you're stuck on a particular question, let me know on Edmodo, and I will try and get a video up on that question on Friday for you. Okay, so this is to be done for Monday. That'll be Monday the 30th, I think. That'll be for Monday the 30th. Okay, the entire of paper 1. So that's going to be a bit of everything. Okay, if you're stuck on a particular question, or you just don't even have a clue how to start a question, let me know before Friday. Sorry, let me know before Thursday at around 6 o'clock, okay? So you have all day tomorrow, all day Thursday basically to see what questions you can do, what questions you can't do. If you can't do a question by Thursday at 6 o'clock, let me know and I'll try and get a video up for that on Friday for you, okay? So that's what you're doing until next Monday, and I'm going to take a look at these now on my iPad. So guys, keep washing your hands. So we're going to take a look at the 2014 paper 1. We're going to take a look at question 9. So let's read through this. A small rocket is fired into the air from a fixed position on the ground. Its flight lasts 10 seconds. The height in meters of the rocket above the ground after t seconds is given by h is equal to 10t minus t squared. Okay, so we have some function here for h, for height, and for every second that it proceeds, the rocket first of all goes up, and it'll reach its max and then it'll start falling back down to earth again. So it's going to be this shaped curve, and we can see that it's going to be n-shaped because we have a negative on the t squared there. Okay, so complete the table below. So it gives us a list of times and it wants us to know the corresponding h's for that. So to do that, I'm going to go into table on my calculator and I'm going to input this function into the table. So we go mode and we go 3, and that gives us f of x, and we're going to put in 10 alpha x minus alpha x squared equals, and we want to start at 0 and we want to end at 10. We want to go up in steps, but from 0 to 1 is 1, from 1 to 2 is 1, from 2 to 3 is 1, from 3 to 4 is 1. So we want to go up in steps of 1. And we get out 0, 9, 16, 21, 24, 25, 24, 21, 16, 9, and then again we have 0. So that's quite a handy few marks there. Just basically, can you use your calculator? If these guys here were not given to you, okay, because I just used my calculator to get this information, I would do it again just to double check my answers on the calculator. But because these were given to us and they agree with my calculator, there's no real need to do that. Okay, draw a graph to represent the height of the rocket during the 10 seconds. Right, so basically plot this information here on a graph. I'm going to make my window a bit smaller just so I can see both things together. Okay, so I can see everything I need to see there. And I'm going to go from 0 to 0, so I'll put a dot down there. And then we want to go from 1 to 9. 1 to 9, so that's about there. 2 to 16. 2 to 16. 16 is about there, I think. 3 to 21. 3 to 21 is about there, perhaps. 4 to 24 is up there. 5 goes to 25, which is up there. 6 goes to 24, which is over there. 7 goes to 21. 8 goes to 16. 9 goes to 9. And 10 goes back down to 0. And then if we can fill this in, maybe red would look well. Okay, so there's a mistake there. 9 is actually over there. 9 is over there. Right, so now back into red. Let's continue on there. Okay, so that's what the function looks like. Okay, seems to be a reasonable thing there. Now I can go back into making it a bit bigger. Use your graph to estimate the height of the rocket. Okay, so I'll make it smaller again, sorry about that. So we're down here now in part C, the height of the rocket after 2.5 seconds. So we want to know the height of the rocket after 2.5 seconds. So we'll go back into my graph, and at 2.5 seconds, so down here, I'm going to draw a vertical line up. I don't know why it's doing that. Okay, anyway, vertical line up from 2.5. And then we want to find the height, so we have to go horizontally across. So maybe 18.2 or something. So 18.2. And that's going to be in meters. Is it, or kilometers? It's a rocket, so we never quite know. In meters. Okay, so 18.2 meters. Not very high really, but anyway. The time on the rocket will again be at this height. The time on the rocket will again be at this height. So it'll be at this height again over here. And the time at which that happens, the time at which this thing here happens, well, I draw a vertical line down and I get 7.5 seconds. That's meters. The coordinates of the highest point reached by the rocket, so the coordinates of the highest point would be that point up there. The coordinates of the highest point reached by the rocket. Not really happy with the phrasing of that question, but anyway, I think I know what they're asking for. So it's going to be 25, comma, so it's going to be 5, comma 25, sorry. So that's the coordinates of that maximum point over there, so 525. Now find the slope of the line joining the points 6, 24 to 721. So 624 to 721. There's a bit of a trap there, chaps. We're asked to find the slope, and we're in a functions question, so they're asking us to find slope, so that probably means we're going to have to differentiate. Yeah, but they're not asking us to find the slope of a function at a particular point. They're asking us to find the slope of a line. So we know when we're talking about the slope of a line, we're going to use the formula. My pen is a bit fat there, I'm going to go back a little bit, okay. So we're going to use the formula m is equal to y2 minus y1 all over x2 minus x1. So I'm going to use that formula on these 2 points here, and that's my x1, y1, x2, y2. So m will actually equal 24 minus, sorry, will equal 21 minus 24 over 7 minus 6, which is equal to minus 3 all over 1, which is equal to minus 3. So the slope of the line joining 624 to 721 is minus 3. I might just plot those 2 points and see if that slope makes sense. So 624 and 721, this point down here. So it's the slope of the line joining those 2 points. So it's going to be going downhill. What colour can I use? It's going to be going downhill anyway, so that's the minus sign taken care of. Something like that anyway. So it's going to be going downhill and it's a slope of minus 3. So that all looks good. Quite a steep downhill slope. Would you expect the line joining the points 721 and 816 to be steeper than the line joining 624, 721? 721, 816. 721 and 816. So which is the steeper line? That one or that one? Well, I would expect the line joining 624. I would expect this line here to be the steeper line, right? So we're going to choose 721 to 816. We're going to choose those two, the line joining these 2 points, because they both run the same amount. But 721 to 816 drops 5, whereas 624 to 721 drops only 3. Find dH/dt. So what am I going to do here? dH/dt. There's H up there. I'll try and grab him somehow. And let's push him back in there. Let's put it there. So H is equal to this guy here. And we want to find dH/dt. Let's go back into blue. And okay. So that's H. So dH/dt, well, that means differentiate. So I'm going to differentiate this guy here. So it's going to be 10 minus 2t. And that's dH/dt. Hence find the maximum height reached by the rocket. Now, we know the maximum height reached by the rocket occurs when this thing here, when this thing equals what? At a maximum in, we let the derivative equal. We let the derivative equal what? Yeah, so 10 minus 2t must equal 0. So minus 2t must equal minus 10. So t must equal minus 10 all over minus 2. So t must equal 5. So 5 seconds. So the rocket reaches the maximum height it will get to after 5 seconds. So after 5 seconds, it reaches its maximum. So the distance from there to there is 5 seconds. But we're not interested in the time it takes to reach its maximum. We're interested in the actual height it attains. So if I know the time, and this thing here is a function for height, I can just put my time into this function. So I'm going to do that now. I'm going to go 10. H is equal to 10 bracket 5 minus 5 squared. So that's going to be equal to 50 minus, I don't know what that thing is supposed to be. 5 in brackets squared. 5 minus 50 minus 25, which is equal to 25. And that's going to be in meters, and that corresponds to our picture that we drew up here. The height from there all the way down to there is 25. Find the speed of the rocket after 3 seconds. Find the speed of the rocket after 3 seconds. Okay, now this thing here is a formula for distance. So how do I go from a formula for distance to a formula for speed? What do I have to do to it? Good, so I'm going to have to differentiate this guy. So I differentiate that, which is this thing here, and that's a formula for speed. So speed is equal to 10 minus 2t, because h, that thing there, that's a formula for distance. And I specifically want to know the speed of the rocket after 3 seconds. So I now go 10 minus 2 bracket 3. So speed is equal to 10 minus 6, which is equal to 4. And then the last part, part F, find the coordinates of the point. Find the coordinates of the point at which the slope of the tangent to the graph is 2. Well, we go back up here. This thing here, that's a formula for all the slopes. So we go 10 minus 2t, that's dh dt. And that's a formula for all of the slopes. So that's all of the slopes. But we want to know specifically, when is the slope equal to 2? Okay, so I then go minus 2t must equal 2 minus 10. So minus 2t must equal minus 8. So t by itself must equal minus 8 all over minus 2. So t must equal 4. Find the coordinates though. So we've only found the t value. We now need to find the h value. So we need some formula for h. And the formula for h is, I probably still have it in my thing. There we go on my clipboard. So there's the formula for h. So I can now go h is equal to 10 times something minus something squared, and those somethings, they're going to be 4. So h will equal to 40 minus 16, so h will equal to 24. So the coordinates are going to be 4, 24. Okay, so that's 2014 question 9. So it was one of the questions you had for homework. Now let's take a look at the other one. So this question we're looking at here, this was the second question you had for homework last night. And it's 2016 question 4. So let's read through it. The function f of x is x cubed minus or plus x squared minus 2x plus 7, and it's defined for x and 4. We don't really need any of this thing here. Basically, this is our function. That's kind of nice, okay? Find the coordinates of the point at which the graph of f cuts the y-axis. So, if I draw a quick sketch here, where a function crosses the y-axis, so let's say we have some mad function. The coordinates of that point, we know one value of it. Well, if it crosses the y-axis there, we know the value that goes in there. We know that that value must be 0. So the first ordinate in the coordinates must be 0. And the moment we turn this x into a 0, and this x into a 0, and this x into a 0, that's going to be, that whole thing there becomes 0, that whole thing there becomes 0, that whole thing there becomes 0, and the only thing we're left with is this plus 7. So the coordinates of this point here, where this function crosses this y-axis, well, it must be 0, 7. Okay, on to part B. Verify using algebra that the point A17 is on the graph of f. So what this is asking us is, if I put a 1 in, do I get a 7 out? So let's try that now. We'll have something cubed plus something squared minus 2 times something plus 7. So that's going to be 1, 1, 1. And I put that into my calculator and I get out mode 1. So I go start bracket 1 cubed plus start bracket 1 squared minus 2 start bracket 1 plus 7 equals, and that's equal to 7. So when I put a 1 in, I get a 7 out. So therefore that point there is on the graph. Okay, look at this. So this is all really easy stuff, guys, okay? Next job, find f prime of x, the derivative of f of x. So if that's f of x up here, I'm now looking for f prime x. So I now go 3x squared plus 2x minus 2. Hence, find the slope of the tangent of the graph of f when x equals 1. When x equals 1, so we're looking for just the slope when x equals 1. So when that's equal to 1, that's equal to 1. So it's quite simply 3 bracket 1 squared plus 2 bracket 1 minus 2. So that's going to be 1 times 3 is 3 plus 2 is 5 minus 2 is 3. So the slope is equal to 3. Easy, easy, easy marks. Basically, can this student differentiate? Hence, find the equation of tangent to the graph. So find the equation of the tangent. Find the equation of the tangent. Find the equation of tangent. So find the equation of tangent. The tangent is just a line. So that means that we're going to use the formula y minus y1 equals m into x minus x1. Find the equation, right? So we're now going to go y minus 7, that's my x1, that's my y1, and that's my m, is equal to 3 into x minus 1. So that's y minus 7 equals 3x minus 3. Everything on the one side with x positive. So that's 3x minus y plus 7 minus 3, and that's equal to 0. So 0 equals 3x minus y plus 4. So that's the entire question 4 there. Yeah. You know, fairly straightforward stuff, and not a lot of kind of storytelling, you know, just good kind of old-fashioned sums, okay? So that's just loads of marks to be picked up for in the functions questions. Okay, so I'll see you guys, I'm going to leave it there for tonight, and I'll see you guys again on Friday. Lads, if you have any questions, if you're stuck on anything on that paper 1 2019, please let me know, and I'll try and get videos up for you on it. Okay, until then, bye.